Hi, now let's see exercise 54, and if you just wonder why it's 54, we're just beginning the topic because I'm going to do this, okay? For this entire chapter of sequences, I'm not going to zero, okay, the exercise. So it's always going to be, okay, a growing number. Now, let's see some exercises. And in here we have identify the geometric sequences. If they are so, okay, we have to identify which is which. And if they are a geometric sequence, we're going to find the common ratio. Okay. Now, let's first this one. Let's take the this one. Now, pi over 2, pi squared, pi to the cube, pi to the 4th power, and so on. So what's going on in here? Let's just understand what's going on. We are just multiplying by pi, right? Okay, so pi is being multiplied. So therefore, it means that q is going to be pi. Okay, so each subsequent term is going to be the previous one multiplied by pi, isn't it? Pi to the 3rd, if we multiply by pi again, is going to be pi to the 4th. So this is a true, okay? And let's put the green one. So this is one that we're going to say it is a geometric sequence. Now let's see this one. 150. So far, it could be arithmetic, it could be a geometric. Why? Because if it is going to be an arithmetic one, so the common difference would be minus 50. It works, but now it doesn't. If it is to be a geometric sequence, then the common ratio would be half. 100 by half 50, by half 25, good, by half also, okay, 12.5. I said, okay, great. So the common ratio, it is as half, and this is our geometric sequence. No, it's not. Because the common ratio in here, it would be half. From here to here, the common ratio would be minus half. And then here, from here to here, it would be again half. So the common ratio, it is changing too much, okay? So that's not good for us. We gotta have something more, I would say, constant, okay? Well, I just put a little bit zoom in here. I think it's going to be better for us to work, okay? Okay, now so this one is not going to be, okay? And why? Let's even put a little bit more zoom in here so it's make better for you to understand, okay, everything that I'm writing. So you see, the common ratio cannot change. This is one rule, okay? The common ratio must be always the same one. It is q. It can't be q minus q, q minus q, 2q, 3q. No, it gotta be a number, okay? Now, so this one is not. C. From here to here, we just divide by 5. Good. Again, divide by 5. And divide by 5. So, wonderful. So, it is a geometric sequence, right? No, again. Why? Can you spot the problem here? There is a single problem in here. And why we can say it's a geometric sequence in here? Try to think a little bit. Yes, exactly. This number here should not be in here. Because if we're going to divide by 5, we're not going to get 0, are we? It should be 1 in here. So just because of this little guy in here, it's not going to be. Okay? Now, let's see some more. D. Let's see. From here to here. Okay? Divide. Let's just multiply. Okay? It's easier. Multiply by minus 1. Now, multiply by negative 1. It works, okay? Minus, plus, minus, plus, okay? Every time we multiply by negative 1, we just invert, okay, the signal, and the number stays the same. Good. So this one works for us. Q is going to be what? Negative 1. And this is going to be what? let's give their names, right? This is going to be an oscillating sequence, geometric sequence. And this one is going to be a growing geometric sequence. Okay, now let's continue. 1, 2, 4, 8, 16. Well, this is by the book, right? Times 2 times 2 times 2. It couldn't be more perfect, okay? Q, it is just 2. There is no reason to say anything, right? Of course it is. And this one, it is 2, I'm sorry. Okay? Because we have a constant common ratio. Now let's see this one. 64, 16. We have to know those numbers, okay? Base 2, like 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Okay? Those you have to know. Base 2, we have to know by heart. Okay? Let's see again. Sorry. 2 is always multiplied by 2. 2, 4, 8, 16, 32, 64. I'm just waiting, okay? To try to be ahead of me, okay? 64, then 128, 256, 512, 1024. Okay? Of course, I made it a little bit slow because you were supposed to be ahead of me. The student must also be like 1 second ahead of the teacher, never behind. Okay, we just have to have a crystal ball to imagine what the teacher is saying. Okay, you should never be behind. Okay, in the vacuum, it's not good. Okay, and when you are in a great synchrony, okay, perfect frequency with the class, you can get 1 second ahead, and sometimes you can even get 10 minutes ahead of the teacher. But well, okay, let's get back to the class. 64 to 16, we are going to divide by 4. Not just 4, right? We're going to divide by my negative 4 because the signal is changing, okay? So whenever the signal is changing, if it is a geometric sequence, it's going to be minus something, okay? Because minus with minus is a plus. Then plus with a minus is a minus. Minus with a minus is a plus, and so on. Negative 4, now in here, again, just multiply by negative 4. Yes, it works. Divide, right? I'm sorry. Division by, I'm sorry. It's always being divided by. Divided by, again, negative 4. So we see negative 4, negative 4, negative 4. Okay? So this Q is going to be what? Negative 4, right? Okay? The next term would be 1/4, positive. The next one, negative 1 over 16. So this one is also good. Okay? Now, let's see some more. Oh, it's supposed to be like this. Okay, now, well, this one, let me just take in here 1 second. Remember what we said right in the beginning? Every sequence of real numbers except, oh, I'm sorry, it's zoomed, right? Okay, every sequence of real numbers except 0. Okay, we cannot have 0 in our sequence. Therefore, this is no way, okay, no zeros, okay, no zeros. It's not going. We can't say, we can even start, okay, 0, it can't be there. Now let's see this one. 1/3, 1/6. From here to here, what did we do? We just had to what? Well, it is getting smaller, so we are going to have to divide by something or multiply by something. I'm going to choose this one, multiply by half. Okay? Now, again, multiplication by half, still half. Again, multiplication by half. It works. Therefore, Q is going to be just half. Good. This one is good for us. Now, We have some interesting ones now. 1/3, 1/6, 1/9, 1/12. What is this? I said, now of course it's not a geometric sequence because we're just adding threes, right? 3, 6, 9, 12. But not even an arithmetic sequence it is. And do you know why? Because we're not adding 1/3. Okay, we can't say that 1/9 plus 1/3 is 1/12. It's not. So it's not geometric, and it's not certainly not arithmetic. So it's nothing here so far. Okay, and it's clear, right? It's not a geometric one because from here to here, Q would be what? Half, right? We just have to multiply by half. But now, look, to go from 6 to 9, well, if we just multiply by half, it would be 1/12, not 1/9. Okay, so this is certainly going to be different than half. Okay? Now let's see this one. 1/3, 1/9, 1/9. So far we had what? Multiplied by 1/3 in here. Again, multiplication by 1/3. Again, multiplication by 1/3. So this is a geometric sequence. In Q, it is just 1/3. And in this case, I just forgot to name those. So in here is going to be a growing, okay? This one is going to be a growing geometric sequence. This one is going to be an oscillating, okay? Oscillating geometric sequence. And in here, the terms are going each time smaller, tinier and tinier, okay? So this is going to be a decreasing geometric sequence, okay? Here, decreasing geometric sequence. Let me put like this, okay? And now, well, let me just put like this in here. And now this last one in here, let's see. So this one is true, it is indeed. And let's see this one, 5 0 5 0 5. And some people say, okay, this is an oscillating. It is oscillating between 5 and 0. Yes, it is oscillating. You are correct. But can we find a common ration here? No, we can't, because from here to here, what? We have to multiply by 0. Not good. And here we have to multiply by nothing, right? So very weird, this one. So this one is nothing, okay? Well, let's just get back, okay, to our initial paper in here. So this is the exercise we have made in this class. A little bit close. Okay, something like this is enough. Now, well, this is exercise, and I hope that doing those exercises it has become to you very clear that first the common ratio must be constant. We cannot have zeros in our sequence, and we have growing, decreasing, we have oscillating, and we have a constant. We made all of them, I believe. The constant, no, we didn't have the constant here. Okay, the constant would be like 2 2 2 2 2, or minus 1 minus 1 minus 1 minus 1, or 21 21 21 21. Okay, so that's for now, and thank you very much. See you next class. Bye bye.